Good afternoon, sir.
Good afternoon. So, all right. Hmm. Good afternoon, everyone. Now, the plan is I've thought about starting uh, this lecture. All right, like from the beginning, because some of you might find it difficult to go through uh, the lectures. All right. Now, the point is, it's very simple. The thing is, you have to think about quantum mechanics differently. All right, you should never compare it with classical mechanics. Of course you should know the differences, but you cannot think of the like in terms of the classical mechanics, otherwise it will create confusion. So there are many things which there is a misconception about, which we'll discuss in the class during the lectures, and make notes. All right, so this will also be uploaded to my channel, YouTube channel called Paper Muni. So okay, so this is Bipla Datta, and I'll be teaching you lectures on quantum mechanics for IITJAM, CSIR, NET, and GATE. Now the first half will cover both the common topics of all the exams. All right, so everybody can attend. And the second half, it will be not the half, it will be like one third of it. Okay, in that case, I'll cover CSR and GET topics. All right, so I'll write down the topics, and you may note it down. All right. uh, I'll also share this lecture in the group, this PDF. So the first thing is, and we'll have 40 minutes or for 1 hour lecture, whichever we find suitable. So this first topic which we'll do is like mathematical tools, which is very important. All right, mathematical tools. Now the problem is in physics, students are sometimes they are incapable of doing mathematics. All right, so I cover the basic ones, where whatever things are it's required in this course, I do it here. So this course anybody can do it, even a high school student can also attend this lecture. All right, it's designed in such a way. All right, so in this case I'll do the mathematical tools. Now this will consist of all the like integration tricks and probability and plotting, okay, and gamma function, beta function. You have done it, but there is another way to look at it. You must have done all these somewhere or the other. Some of you might know also, but there is a technique to do it which will be useful during our course. All right, so just the perspective will change, and you'll see that you are able to solve more problems of the previous year exams. So these are the mathematical tools. Then we have the wave function. Now usually you'll see in the books that the people start with photoelectric effect and Compton scattering and black body radiation. So these are of course quantum phenomena, but the theory is semi-classical in nature. Means the theory is not completely quantum mechanical. Only one step is quantum mechanical, which is E equal to h nu. All right, so that is quantum mechanical, and rest, like in photoelectric effect, the rest of the part is classical calculations. All right, now that distorts our everything, the concepts and every imagination whatever you try to do. The best part to start is with spin, but spin then again becomes very abstract. All right, so the process where I go is like this. I do the wave function. Before that, I do actually the de Broglie wavelength, de Broglie hypothesis. All right, so this is where I start from, de Broglie wave. All right, so de Broglie wave. Now this is operator formalism. Next is operator formalism. Operators are very important because like the mathematics which is used is linear algebra, and this or it's called it's a part of it. The operator algebra is a part of this linear algebra. Okay, So we will learn about some commuter bracket and other properties of it, and operator, some properties of operator, linear operators. All right. Now next one is this is Schrodinger equation. We'll do Schrodinger equation after that. Now I'll tell you which exams will have which questions, like which topics will pertain to which exams. So this Schrodinger equation is the next topic we'll do. And then we'll have this box potential. All right. Now box potential is like, we'll do this 1D potential, which is 1D, we'll do 1D, 2D, 3D. All right. Then we'll also do eigenfunctions and eigenvalues. Eigenfunctions, eigenvalues. Now it's very important to know what is in the syllabus. All right. So I generally go through each and everything. If you know what you have to learn, then half of your problems get resolved. So degeneracy, okay, and 2D and 3D. Now next is linear harmonic oscillator, another very important topic. Linear harmonic oscillator. If you have already gone through the lectures on YouTube, that's good. You learn something you learn here also. Okay, not every lectures are same. I try to add something or the other with every lecture I do. So this is eigenfunctions and eigenvalues. All right. And then again, we have this topic, which is degeneracy. We'll learn each of them. What are they and why we study them. Next, like 7 pointers, step potential, okay, and rectangular barrier, Then we have finite potential well, or finite well potential. All right. Now some topics are not there in JAM, okay, but even if you don't have it in JAM, you should know this, because once you go to IIT, you'll be expected to have some knowledge of that. Okay, so some knowledge of whatever topics we are discussing here. So it's better if you learn here. Bohr's model. Then we have energy eigenfunctions. Right. Now, last is degeneracy. Right. Now on this side, there's no space here. Maybe I'll continue below. So next one is Pauli exclusion principle. All right. Like when we have fermions and bosons filling up 1D potential, 2D potential, 3D potential, or any potential. So in that case, we'll use the Pauli exclusion principle. Then we have nowadays it's very popular with the examiners, which is Dirac delta potential. Okay, so Dirac delta potential. Now Then we have spin and angular momentum. Now spin and angular momentum has two parts. One will be for the like MSc entrance level or integrated PhD level, and one entrance, and other will be at the net and gate level. So you can stop when I say that, yeah, like I'll be discussing gate and net. You can stop there, but when do all the topics which I suggest for the MSc entrance level. So next one, now after this, what happens is we'll do this identical particles. Okay, so let me write down all the jam part now. Now after this, what we'll do is we'll do this thing. Now the topics which we left in the beginning, which is photoelectric effect, which is very popular in jam. Jam questions, jam paper, they ask a lot of questions from these. So photoelectric effect. Then you have Compton scattering. Compton scattering. All right. Now then we have black body radiation. Black body radiation. All right. And then we have this uncertainty principle is another topic which is very important. I'll do it somewhere in the between, but I'm writing it here. Uncertainty principle will do. Uncertainty principle. All right. Now the other topics are like we have left this out, that group velocity and phase velocity. Group velocity, and this is another favorite of JAM. Velocity, phase velocity. Now questions are also asked from this topic in optics also. All right. So you'll find the concepts learned here useful in that subject. Now now comes the gate and net level. So all the topics are common from like top to bottom. Like it's all common for both IITJAM, CSIR-NET or gate. So now exclusively it is net or gate. Now identical particles. Identical particles is one topic. All right, identical particles. Then you have scattering. And then we have let me write it here, perturbation theory. All right, now these topics are not very difficult. Okay, if you go through these lectures, it will seem very easy. Now perturbation theory is there. Then we have this WKV approximation. And we have this variational principle. All right, so these are the tentative topics, and we'll learn according, like now these topics are exclusively for net and gate. This topics, CSIR and net and gate. All right, so the MSc people can leave this part. MSc entrance candidates, this is net and gate. Now till here from top to bottom, this will require, I'll give you a tentative schedule. Now this till here, it will require around 55 to 60 hours, and it will cover all exams, we'll do most of the numericals from previous years, okay, in class itself. So it will cover most of them, and then these topics will take around 30 to 35 hours. All right, so total is like around 80 to 90 hours. Okay, 90, not 90, yeah, 95 hours, something like that. So let's make it 30 hours. 30 hours is more than enough. Yeah. So total course, whoever is doing the complete course will be like the whole, if you're preparing for CSIR-NET and GATE exams, then the total course is 90 hours. All right. and I'll do the complete course. Okay, I'll do the complete course, and it will be completely free online. Whoever wants to attend this lectures, they have to fill the form, and the next day I'll upload the videos of this. So you can also look in the YouTube, but it's very good if it's more efficient if you attend the lectures. All right. So in this case, this is my schedule. So complete for JAM and MSc entrance exams, TFR just this part till here, it's like it's there. And see, these are asked, I'll go through the topics. Now these are asked, the first topics, this operator formalism is rarely asked in JAM. Okay, this is just and TFR, another DU. Okay, just TFR, DU. Okay, but and then this Schrodinger equation and everything is asked in JAM. Now in this thing, the finite potential well is again just and TIFR. Okay, just TIFR and yeah. And this hydrogen atom Bohr model is JAM, but eigenfunctions and degeneracy, these are like in just and TIFR. Okay. And this Dirac delta function, the Dirac delta potential, this one and this one, these are also just and TIFR. And rest which I have not marked as JAM, exclusively JAM. These are all JAM. Okay, these are all JAM. And see, whatever I'm not saying is it's JAM. Like they are also included in just and TFR. I'm separately mentioning that which is only for just and TFR. Okay. So this is the tentative syllabus, and I can assure you that if you are regular with the class and just keep revising and remembering things, you'll need only 1 hour of class and 1 hour of revision, okay, for each class. That will be more than enough to score, like whatever exam you have, you'll be scoring 100% marks for quantum mechanics. I can assure you that. All right. So this was the feedback given to me by my ex students. All right. So we'll start with the integration part. Now you have to be fast with your calculations. So these are the tricks which will help you. So integration, we'll start with integration. All right. So the first one is, so the first type is like there's a type to it, type 1. All right. So you have this format X. Now if I want you to okay, now this is an example which I want you to do. This is an example. So if I give you this X sine X and dx, so what will you do? You'll apply by parts, right? So what do you get? What will you get if you apply by parts? This is minus cos X, then plus sine X. All right. Now plus some constant. If you do this by parts, you'll get this result, right? Now this seems very straightforward. We have been doing from childhood. Okay. So, but sometimes these terms are not linear, means they have a power, okay, which is not 1. So if I like this, we'll do this form 1. Okay. So in this form, you have this condition. This is x to the power n sine kx. All right. Now it's dx. Now k is some constant. K is some constant, and this is an integer. This should be an integer, and this should be which is greater than 0. This should be an integer which is greater than 0, and this is like a constant. K is constant. All right. And the power of sine. The power of sine should be 1. You have to make sure that if this matches with this thing, power should be 1. Then only you can apply this trick. All right. Now this is k is constant here. I have already written down. Now the way of doing it is this. You just make 2 columns. You make just 2 columns, which is differentiation and integration. Okay. So what we want here is, we'll keep the term here, which is this x, which we differentiate. X we differentiate once. We differentiate once with respect to x. What will we get? 1. Then again we differentiate. Okay, we get 0. Right. Now in this case we have this sine x. sine kx. Now in this case we'll integrate. If we integrate, what we get? Minus 1 by k. Now in this case, what will we get? 1 by k. Now let's do this example, okay, what we have taken here, and using this same example we are solving it. This same example, you are solving it using this method. All right, so in this case the sign here is, this is sine x. All right, so what we have here, if we integrate this thing, so we are integrating this, we'll get minus cos x, and then again if we integrate this, you have minus sine x. All right, now this is, now the thing is, you have to draw diagonal lines like this. Draw the diagonal lines and start with plus sign, and alternately place minus, plus minus, plus minus. It will go like this. You have to stop when the 0 comes. You have to stop when the 0, you arrive at a 0. All right, this is a rule which you do. Now in this case, where the integration is sine x dx is equal to, this will give you, now what you have to do, you have to take the product. This x has a plus sign, this is a plus and this is a minus. So if you do a product, you'll get minus x cos x, and then the next term is, this is plus, this is minus, this is minus. So this will be plus sine x. All right, then you have a constant of integration. So this seems very simple, and you can do it with by parts also, no problem. But the complexity increases when we have the powers of x. Okay, so is this clear to everyone? Is this method clear to everyone?
Yes, sir.
Yes, sir.
All right. So then we have this thing that the next example let's try is, next example is x square sine kx, all right, and dx. Now this is, you have to find out this. Okay, so let's see how to do it. Now we'll make 2 columns. All right, this is x cube. Now this is integration. Next column is integration.
Sir, it's x square, sir.
X square, x cube. Okay, I wrote by mistake x square. All right, so in that case, what will happen? You just write this. So if you differentiate this, what will you get? 2x. You'll differentiate this, will get 2. This will, you will differentiate, you'll get 0. So you stop here in this column. Now you have to integrate this column like till you get to this part. So this will be 1 by k minus cos kx. Then you have minus 1 by k square sine kx, and you have this thing k cube, and this will be cos kx. All right, so in this case, what will you have? A minus sign will go away, so this will be the integration parts you have. So you'll get, now start with plus, minus, plus. All right, so you can write this integration as, let's call this okay, let's write the x square sine kx dx. All right, so this will be if you might like write in multiplication, x square plus this minus, so this is x square by k cos kx. All right, now next term will be minus plus 2x by k square sine kx. All right, plus 2 by k cube, this is, you get cos kx. Now you stop. Now you have a plus some constant of integration. So see, it's very simpler when the point to here is, when you have integration by parts, there are chances that you'll make mistake of signs. Okay, so this process reduces that thing, and it's very easy to write. Now whatever power you want, you can keep on writing like that. But if I increase this to x to the power 3 or 4, then it's very easy to use this method. All right, so try it once. The next
term minus aayega na?
First term, yeah, there's a minus sign. You're right.
Yes.
Yeah, I just missed this thing. Okay, yeah, right. So this is 5 minus, and then we have a plus, then we have plus. All right, this is fine. Everybody's getting this result?
Yes, sir.
Yes,
Okay.
sir.
So like try this for homework. Okay, so try this for homework. This is x cube cos cos kx. So it could be cos or sine. Okay, in both cases it will valid. It will be, this trick will work, but you have to make sure the power is 1 in this case. So x cube cos x. So you have to find this integration using this method. All right, you can do it. It's very straightforward. Now there's form 2. Form 2. All right. Now if you have this form, now this is the exponential form, e to power kx dx. Now in this case also, the power of x here should be 1. Then only you can apply this trick. And this is again an integer. N is again an integer. So n is integer. N is integer and k is constant. All right. So this form, you should be able to compare this form. You cannot apply everywhere. This trick doesn't apply, but whatever integrations you get in and this your quantum mechanics, this is what you can solve using this method, most of them. Okay, so this kind of integration comes when you do hydrogen atom problem. Okay, so this integration helps you there. So how to solve this? Again, we'll make 2 columns, x square, and then we have integration. Now the thing is, we are taking x square because we'll take that part. We will not take here exponential part because we cannot finish it off. Like it's like you can finish this term by differentiating. Like you can reduce it to 0 by differentiating several times. Okay, but this term cannot be reduced by differentiation or integration. So you place this term in the under integration. All right. So and this is the same method which I use while integrating by parts, but mostly whenever the form is like this, I use this method. So this is if you integrate this once, now this will be 2, this will be 0. Okay, so and this one will be 1 by k square e kx, 1 by k cube e kx. All right, so this will connect like this. Will connect like this plus minus plus. All right, so in this case, what will you get? The integration was x square kx dx. Now you can use this in definite integrals also. You just do the integration and then put the limits. Okay, so that's why I'm doing the indefinite part only. The process is the same, but don't put limits in between. After writing the final form, then only you put the limits. All right, so this will give you x square by k e to power kx minus 2x by k square e to power kx. Then we have plus 2 by k cube e to power kx. All right, plus c. Okay, so is everybody getting this result?
Yes, sir.
Yes, sir.
Okay, now after this you take this example. Now let's do this example. This is x square sine square pi x by L dx. Now L is a constant. We'll have this kind of integration in 1D potential. So L is constant. All right. Now pi is pi. So how will you do this? You have, how will you apply the trick? You cannot apply it directly here because the power here is not 1. This power is not 1. So what you have to do is to reduce it to something which has the power 1, which has power 1. So what
we convert in the form of cos theta, sir.
Yes,
Cos 2
so
theta.
you can write like this. So you can write 1 by 2. You can divide by 1 by 2 and multiply, and you'll get this thing. This is 2 pi x by L dx. Right? We can write like this. Now you just take this terms. So this is first term is x square dx minus this will be x square cos 2 pi x by L dx. Right? Now in this case, in this case, what will you have in the first term? You'll have x cube by 6, x cube by 6. All right. Now minus 1 by 2 x square, and this will be now integration. This will be integration. Okay, let me. So this is integration cos 2 pi x by L dx. Okay, now this is the form. Now what? Now you can apply the trick. Now we can apply the trick. So you can do it. I'll not do this one. You just apply the trick, you'll get the answer. Okay. So I wanted you to show that this part, this kind of expression can be reduced to this format, and then you can apply the integration, like the trick I showed you. All right. So you can solve this. So you can, this is not a big thing to do. So you can solve it using the trick I showed you. Okay. So is there anyone who cannot do it? Everyone can do it?
Yes,
All
sir.
right. So next one is,
Almost over.
huh? Sorry?
Almost over, sir. मतलब half complete कर लिया.
Okay. So now next is factorial function. Factorial function is another great tool which I love to use during calculations wherever possible. Factorial function. Okay. So factorial function, like if you have this integration, now if you have this definite integral 0 to infinity e to power minus alpha x dx. All right. So if you integrate this, what will you get? This is minus 1 by alpha e to power minus alpha x 0 to infinity. So if you put this, what will you get? Minus alpha 1 minus, so you'll have e to power minus infinity minus e to power 0. So this will be 1 by alpha. Okay. So this is, say, one equation, number 1. Is this clear to everyone? It's simple integration we have come across earlier also. Now there is something called differentiation under integral sign. Now this was very favorite of Feynman, Richard Feynman. Have you heard about him?
Yes, sir.
Yes, sir.
Okay, so his favorite was this differentiation under integral sign. There is differentiation under integral sign. Differentiation under integral sign. So there are questions in TFR. I don't have it. I don't remember them now. Right now, maybe next class I'll show it to you. They look like you'll be able to solve only using contour integral. Okay, but that is deceptive. What you needed to do in those cases where that you have to differentiate under the integral sign. Okay, I don't have the questions. I don't remember exactly, but I'll show it to you in the next, maybe in the next class. So this technique is very useful, and there are some questions asked in JEST also, in TFR also. Okay, and so in mathematical physics portion. So what we'll do here is we'll differentiate equation 1 with respect to alpha. All right. So in this case, we have the integration. Okay, we do not touch anything related to x. We just use differentiation with respect to alpha. Okay, so wherever the alpha comes, that will be treated as variable, and other things like x, okay, dx will be treated as okay. So other things which is like other than alpha, it will be treated as constant. Okay, so if you differentiate this, what will you get? Now this will be 0 to infinity minus x e to power minus alpha x dx. All right. Now this this side will be minus 1 by alpha square. Right. So if you just simplify this, now my alpha looks like d. Okay. So this is alpha, all right? No, it's not D. Now, if you now further, if we write like this, that if you remove the signs on negative signs on both sides, we'll have this expression. All right. And if you want to do theoretical physics, then remember that your mathematical skills should be really good. So these are the tools you should keep on learning. Okay. So next is again we'll differentiate. Now this is equation 2. Say this is equation 2. We'll differentiate again. Differentiate equation 2 with respect to alpha. All right, with respect to alpha. Now in this case, what will you get? Now we are differentiating this one. Okay, this thing we are not differentiating because already we have removed the negative sign. This will be how much? So what will be the now you differentiate with respect to alpha. So what will you get? 0 to infinity minus x square e to the power minus alpha x dx. This side you'll get 2 by alpha cube. So if you remove the negative sign, you'll get 0 to infinity x square minus alpha x dx equal to 2 by alpha cube. Now this is say equation 3. Okay. So now where did this line come from? Is somebody writing on this thing? I forgot to switch off the, like, somebody's writing on this screen also. Please don't write on the screen. I forgot to switch off this thing. This is okay, but there is, I have to change this. That's why I'm not able to delete it. This red mark. There's some issue. I have to change the settings here.
So please disable annotation.
Huh? Disable annotations.
Disable
I'm not able to, disable annotations for others. Okay. So this thing has to be, I cannot delete it now, this part. So make sure that you don't write on the screen. Somebody called Punk, somebody wrote, I don't know who was it, who drew this thing. All right, so this is now next one is we'll differentiate again, and we can directly write this down. So this is, we can write at 2 factorial, or right? 2 factorial by alpha cube. Now again we'll differentiate, again differentiating with respect to alpha. Again differentiate with respect to alpha. All right, so in this case what will happen? 0 to infinity. Now this is x cube e to the power minus alpha x dx is equal to minus 3. Now this will become 3x. Now this side will be 3. Now if you differentiate this, what will you get? This is x cube, this is fine. Now this side it will be minus 3 into 2 factorial divided by alpha to the power 4. Now again rearranging this thing, we'll get 0 to infinity x cube e to the power minus alpha x dx equal to, this will be 3 factorial divided by alpha 4. Now we have a trend here. All right, what is the trend? Now one can see that you can write like this: 0 to infinity. Now this, if you represent this as x to the power n, this is minus alpha x dx, okay, equal to, now this is n factorial divided by alpha n plus 1. All right, so this is what we are getting, where n is an integer. Right? Clear? N
Yes, sir.
Integer. All right, now this is what you should remember from here. Right, this is what you should remember from here. Now if you put alpha equal to 1, what will you get? You will get 0 to infinity x to the power n e to power minus x dx. You'll get n factorial. All right. Now, if you put n equal to 0, what do you get? 0 to infinity x to power 0 e to power minus x dx is equal to 0 factorial. Now this will be 0 to infinity e to power minus x dx. This will become e to power minus, like this will be minus ex 0 to infinity, and this will give us minus infinity to power minus infinity minus 1. All right, so this will be 1. Now one can see that now 0 factorial is 1. You can see that 0 factorial, there's a simple proof here. 0 factorial is 1. Okay, so we actually proved 0 factorial is 1. All right, so everybody knows this, but this is how you prove it. Here's one of the ways. Now next is the gamma function. All right, so in this case, we just briefly describe it. This is gamma n is 0 to infinity x to the power n minus 1 e to the power minus x dx is equal to n minus 1 factorial. All right, and gamma n plus 1 is equal to 0 to infinity x to the power n e to the power minus x dx is equal to, this is n factorial. So you have to remember either of them. Okay, now we have this property that gamma n plus 1 is equal to n gamma n. All right, and we'll remember this, that gamma half is equal to root pi. All right, so this is, so example, if you take, what will be gamma 4 or 5, whatever it is. So gamma 4 will be 3 factorial, which is 6, and gamma 3 by 2 will be, this is, we can write gamma
1 by 2 gamma
1 plus 1 by 2, this will be half. We can use this the property, and we'll get 1 by 2 root pi. Yeah, now this one, can anybody prove this thing? E to the power minus x square dx is equal to root pi. You should remember this formula. Can anybody prove this? How will you prove? Any idea?
taking x square equal to t.
We'll put x square equal to some t.
Okay. Then,
so we can use double
Then we take
integration
x
and change
for
to
n
polar
and
coordinates.
yes,
0.
we can, like, it's better to use polar coordinates. Okay, so you take two integrals. One is this with x, and other you take in terms of y,
Why?
and then multiply them and convert it into, from Cartesian to polar coordinates, and it gives you a very clear like answer. So this was also described in Feynman's of lectures of Feynman, this method. Okay, and in several books you'll find it, but I first came across this method in Feynman lectures. All right, there was a footnote where it was mentioned. Now this other thing which we want you to remember is this form, which is minus infinity to plus infinity. All right, e to the power minus alpha x plus b whole square dx is equal to root over pi by alpha. Okay, so this is the form. Now this is again not a d. So this is another form which you should remember. You can derive it, but these are the integration you should remember for your quantum mechanical class. You should remember this. I'm not like deriving it. So next is this is very important. This is very basic. Some of you know, some of you make a mistake, and sometimes get confused also. So even function and odd function. All right. So in this case, if we like the first thing, if f of minus x is equal to fx, okay, then fx is said to be even function. All right, then fx is said to be even function. Now examples we can have x square, x4, okay, and then we have cos x. All right, these are the examples. Now if we have this thing that if fx, f of minus x is equal to minus of fx, then fx is said to be odd function. All right, so examples, x cube, x, okay, then sine x, these are the examples. Now tell me one thing, set e to the power minus kx, is this odd or even? Hello,
So
is
it's
anybody
neither
there?
odd nor even.
Yeah, so
Um,
it's
neither
neither
odd
odd nor even. Okay, so if you want to if you put this thing, how can you write, like if you put a minus x here, if you put a minus x, now in this case what will happen, just put a minus x here, so this will be minus, this is minus x, this will be e to the power, this is kx. Now this is not equal to the function in any way. All right, the function changes, so this is neither odd neither even, so the function is neither odd nor even. All right, so is this clear to everyone? Now if there's some integral rules, okay, if fx is odd, all right, now this is say minus a to plus a, so if you have fx dx, what you should get, 0, right? Now if you have an like integration like this where you have an odd function, all right, now these things might seem trivial, but people make mistakes, so in this case this will become 0. Now if you have, if fx is even, all right, what will you get, minus a to plus a, now this is fx dx, all right, so you'll get, so in this case you won't get to be 0, you'll get 2 0 to a, and this is fx dx. All right, so example, in this case if you take example, all right, this will be minus a to plus a x square dx. All right, so this will, we can solve this thing like if by putting the limits also as it is given, but we can reduce it to this problem. All right, so this is clear. Now we have the example, next example is minus infinity to plus infinity x e to the power minus x square dx. Now this will be what will be the answer?
0, 0.
0. So the thing is, if you have odd function and in multiplication you have odd function, you will get even function. You have odd and even function, all right, so you get odd function, and if you have even and even function, you get, this is even function. All right, so this is the combination you have. And now next formula which one should remember is this one, which is very important. In fact, whatever I am doing is important. but you should remember these ones. Okay. Now 0 to infinity, this is the form of the expression, like the integration. This will be equal to gamma n plus 1 by 2 divided by 2 into alpha n plus 1 by 2. All right. Now let's do an example. Now this is very important. Okay. Now example is 0 to infinity x square e to the power minus alpha x square dx. What will you get? So this is gamma 2 plus 1 by 2. This is 2 alpha 3 by 2, and this will be giving you gamma half gamma 1 by 2. This is a 2a 3 by 2, and finally you have root pi by 2 divided by 2a 3 by 2. All right. So this is what you get. Now the other example is, if you have, say this is example 1, example 2, which is minus infinity to plus infinity x cube e to the power minus x square dx. So this will be what? What is the value for this? So this is odd and even function, right? Odd even will give you odd function, and these are symmetric limits, so this will become 0, right? Now next are the plots. Okay, plots are really important because you have to draw wave functions. I'll start with very basic plot, which like already everyone knows. Okay, but then build up from there. Okay. Now in this case, this is say y, this is x, so, and this is theta, and the slope is given by tan theta is equal to m. Now in this case, say the intercept is c, so we have y is equal to mx plus c. All right, this is fine, no problem. Now m is the slope and c is the y-intercept. C is y-intercept. All right. Now what happens when we shift a little, say things a little bit? Now this is, say this was the plot 1. Now next is plot 2. Now in this case, if you draw this a graph, if I give you a graph, and in this case, if you want to draw y equal to x, so you'll have this line. Okay, y equal to x, fine, no problem. Now we have, if you want to draw y equal to x minus 1, which side it will go? Y is equal to x minus 1. Will it go above or below this? If you draw this, so this will be, okay, this will be like this. So in this case, this is y equal to x minus 1. Now if you want to plot y equal to x plus 1, now this will be what? These lines, this will be x equal to 1, this is 1 comma 0, and this will be 0 comma minus 1, right? And if I wanted to plot y equal to x plus 1, so it will come somewhere here. This is y equal to x plus 1. So this is 0 comma 1, and this one is minus 1 comma 0. All right. Now this is very important because we'll be plotting there are questions which has been asked when we have a shifted harmonic potential well. So what to do in that case? Now this looks very simple. Okay. So the thing is, if whenever we have this thing that we have y is equal to x plus a, where is a term added to x, okay, then in that case the graph moves, the plot or the line, the plot moves towards the towards the left of origin. All right. It might looks very trivial, but when we do complex graphs, then it helps a lot. Now, if you have x minus a, now I'm just subtracting from x. X should have a power 1, and we are subtracting a term from that. So what we'll get is, this will move the plot. The plot moves towards the right of origin. All right. So in this case, we are assuming that a is greater than 0. So we'll I think we should stop here because only like it's 3 or 4 minutes left. Otherwise, it will be like stretched more further. All right. So we'll do in the next class. And if we go for 1 hour daily, I think we'll be finishing JAM syllabus by December end. Okay, so quantum mechanics, and NET will be, if you know, finished before gate exam, which is held in February.
It is 6th of February, sir.
Yeah. So, but if we do 1 hour every day, then we'll be able to cover gate by gate exam, gate and NET like by a gate exam, and JAM will be covered by December end, or maybe 1 week extra. All right. So yes, tell me.
सर वो पीछे जो आपने केस लिया था n equals to 0 वाला x की पावर n e to the power minus alpha x 0 to infinity.
Okay.
सर उसमें 1 upon alpha आना चाहिए.
कहाँ पे?
सर
यहाँ पे we had done alpha is equal to 1. यहाँ पे we have taken this also. Both are there. All right. Actually, this was a continuation of this only. Okay.
Thank you, sir.
All right. So, is there any doubt? Shall we sign off?
No, sir. Got it. Everything.
No, I'm asking everyone. So,
No doubt, sir.
Yeah. All right. So some of you have already watched the videos on my channel.
Yes, sir.
Yeah. So
Yes, sir.
that's why you know already some of them. Okay, no problem. Because see, what happened was when I did the lecture of like in the previous lecture which I did that time, I was like I was not sure that what should I tell and what should I not, because I didn't know that how many of you have already done or went through the topics. So it's better if we start from the very beginning, and that's why I decided to do it right this way. All right. So
Daily it will be at 3 p.m. or
yeah, 3 to
time will
4,
change.
3 to 4, 3 to 4.
Yeah, it's good.
Okay,
Because
sir.
if you do a night schedule, it's very hectic for everyone. Okay.
Yes, sir.
10
Yes,
to
sir.
11 is very odd time, and most of you try to take rest that time. And then this time is you can like feel sleepy, so it's better to attend something, learn something. All right.
Thank you so much, sir. Sir, this course was much needed.
Yes,
Yeah.
sir. Thank you so
So-
much.
Yes, sir.
Yeah. All right, but I want, yeah. So I want that you should be regular, and okay, I'll give my best, and hopefully you'll be in IIT or some good institutes in next year. All right. So that is my
Thank
Thank
you,
you,
plan.
sir.
Thank
All
you,
right.
sir. We'll give our best too.
Thank you.
Thank you.
Yeah. Okay. Thank you. Take care. Bye.
Thank you, sir.
Okay.
Thank
Thank you, sir.
All right. Thank you.